This presentation covers Chapter 11, Work and Energy from the CBSE Class 9 Physics Curriculum, describing work scientific conception of work done by a constant force energy, kinetic energy, potential energy of an object at a height, are various energy forms, interconvertible law of conservation of energy, rate of doing work. Commercial unit of energy describing. Work is said to be done when a force acts on an object and the object is displaced in the direction of force. The work done on an object is the product of the force applied and the displacement. Work done equals force multiplied by displacement. W equals F multiplied by S. The unit of work is joule, J. If a force of 1 Newton displaces an object by 1 meter, then the work done is 1 Newton meter or 1 joule, J. For example, if a force of 5 newtons acts on an object and it is displaced through 2 meters in the direction of the force, then work done is 5 newtons multiplied by 2 meters, which equals 10 newton meters or 10 joules. Scientific conception of work. The work done by a force may be positive or negative. The work done by a force is positive if the force and displacement are in the same direction. The work done by a force is negative if the force and displacement are in opposite directions. The work done by a force is zero if there is no displacement. The work done by a force is zero if the force is perpendicular to the displacement. Work done by a constant force. How is work defined in science? To understand this, we shall first consider the case when the force is acting in the direction of displacement. Let a constant force, F, act on an object. Let the object be displaced through a distance, S, in the direction of the force. Let W be the work done. We define work to be equal to the product of the force and displacement. Example 11.1. A force of 5 newtons is acting on an object. The object is displaced through 2 meters in the direction of the force. If the force acts on the object all through the displacement, then work done is 5 newtons multiplied by 2 meters, which equals 10 newton meters or 10 joules. Example 11.2. A porter lifts a luggage of 15 kilograms from the ground and puts it on his head 1.5 meters above the ground. Calculate the work done by him on the luggage. Solution. Mass of luggage, m equals 15 kilograms, and displacement, s equals 1.5 meters. Work done, w equals f multiplied by s, which equals m multiplied by g multiplied by s. This equals 15 kilograms multiplied by 10 meters per second squared multiplied by 1.5 meters. This equals 225 kilogram meters per second squared meters, which equals 225 Newton meters, or 225 joules. Work done is 225 joules. Energy. The energy of an object is its capacity for doing work. The unit of energy is the same as that of work, that is joule, J. 1 joule is the energy required to do 1 joule of work. 1000 joules is 1 kilojoule. There are different forms of energy. They are heat energy, light energy, electrical energy, chemical energy, mechanical energy, which is potential energy plus kinetic energy, etc. Kinetic energy. The kinetic energy of an object is the energy possessed by the object due to its motion. All moving objects possess kinetic energy. A falling coconut, a speeding car, a flying aircraft, flowing water, blowing wind, a running athlete, etc. possess kinetic energy. The kinetic energy of an object depends upon its speed. An object moving faster has more kinetic energy than an object moving slower. The kinetic energy possessed by an object of mass m and moving with uniform velocity v is given by Ek equals half multiplied by m multiplied by v squared. An object of mass 15 kilograms is moving with a uniform velocity of 4 meters per second. What is the kinetic energy possessed by the object? Solution. Mass of the object, m equals 15 kilograms. Velocity of the object, v equals 4 meters per second. From the formula, E sub k equals half multiplied by m multiplied by v squared. This equals half multiplied by 15 kilograms multiplied by 4 meters per second multiplied by 4 meters per second. This equals 120 joules. The kinetic energy of the object is 120 joules. What is the work to be done to increase the velocity of a car from 30 kilometers per hour to 60 kilometers per hour if the mass of the car is 1,500 kilograms? Solution: mass of the car, m, equals 1,500 kilograms. Initial velocity of car, u, equals 30 kilometers per hour. Converting to meters per second, u equals 30 multiplied by 1000 meters divided by 60 multiplied by 60 seconds, which equals 8.33 meters per second. Final velocity of the car, v, equals 60 kilometers per hour, which equals 16.67 meters per second. The initial kinetic energy of the car, EKI, equals half multiplied by m multiplied by u squared. This equals half multiplied by 1,500 kilograms multiplied by 8.33 meters per second squared, which equals 52,041.68 joules. The final kinetic energy of the car, EKF, equals half multiplied by 1,500 kilograms multiplied by 16.67 meters per second squared, which equals 208,416.68 joules. Thus, the work done equals change in kinetic energy, which is EKF minus EKI, which equals 156,375 joules. Potential energy. The potential energy of an object is the energy possessed by the object due to its position or shape. For example, if a rubber band is stretched and then released, it regains its original position. When stretched, energy is stored as potential energy. If we wind the key of a toy car and place it on the ground, it moves. When wound, energy is stored in the spring as potential energy. If we lift an object to a height and release it, it falls down. When lifted, energy is stored as potential energy. An example is an arrow on a stretched bowstring. Potential energy of an object at a height. When an object is raised to a height, its energy increases because work is done on it against gravity. This energy is called gravitational potential energy. If an object of mass m is raised to a height h from the ground, the force required is equal to its weight, m multiplied by g. Work done equals force multiplied by displacement, which equals meters multiplied by g multiplied by h. So, potential energy gained by the object, EP equals m multiplied by g multiplied by h. Example 11.5. Find the energy possessed by an object of mass 10 kilograms when it is at a height of 6 meters above the ground. Given g equals 9.8 meters per second squared. Solution: mass m equals 10 kilograms, height h equals 6 meters, g equals 9.8 meters per second squared. Potential energy equals m multiplied by g multiplied by h, which equals 10 kilograms, multiplied by 9.8 meters per second squared multiplied by 6 meters, which equals 588 joules. The potential energy is 588 joules. An object of mass 12 kilograms is at a certain height above the ground. If the potential energy of the object is 480 joules, find the height. Given g equals 10 meters per second squared. Solution: mass m equals 12 kilograms, potential energy EP equals 480 joules, EP equals m multiplied by g multiplied by h. So, 480 joules equals 12 kilograms multiplied by 10 meters per second squared multiplied by h. This gives h equals 480 divided by 120, which equals 4 meters. The object is at a height of 4 meters. Are various energy forms interconvertible? And 11.2.6 Law of Conservation of Energy. The conversion of energy from one form into another is called transformation of energy. When energy is converted from one form to another, the total energy always remains the same. The law of conservation of energy states that energy can only be converted from one form to another. It can neither be created nor destroyed. The total energy before and after the transformation remains the same. For example, let an object fall freely from a height. At the start, the potential energy is high. As it falls, potential energy changes into kinetic energy. The potential energy decreases and the kinetic energy increases. When the object is about to hit the ground, the kinetic energy is largest and potential energy is least. But the sum of potential and kinetic energy, the total mechanical energy, is constant at all points. Power is the rate of doing work. If W is the work done in time t, then power equals work divided by time. P equals W divided by T. The unit of power is watt, W. 1 watt is the power of an agent which does work at the rate of 1 joule per second. 1 watt equals 1 joule per second, or 1 watt equals 1 joule per second. 1 kilowatt equals 1000 watts. 1 kilowatt equals 1000 watts. 1 kilowatt equals 1000 joules per second. Two girls, each of weight 400 newtons, climb up a rope through a height of 8 meters. Girl A takes 20 seconds, while girl B takes 50 seconds. What is the power expended by each girl? Solution. I. For girl A, weight equals 400 newtons, height h equals 8 meters, time t equals 20 seconds. Power P equals work done divided by time taken, which equals m multiplied by g multiplied by h divided by t. This equals 400 newtons multiplied by 8 meters divided by 20 seconds, which equals 160 watts. T. For girl B, weight equals 400 newtons, height h equals 8 meters, time t equals 50 seconds. Power P equals 400 newtons multiplied by 8 meters divided by 50 seconds, which equals 64 watts. Power expended by girl A is 160 watts. Power expended by girl B is 64 watts. Commercial unit of energy. The commercial unit of energy is kilowatt hour. 1 kilowatt hour is the energy used in 1 hour at the rate of 1 kilowatt, or 1000 joules per second. 1 kilowatt hour equals 1 kilowatt multiplied by 1 hour, which equals 1000 watts multiplied by 3600 seconds, which equals 3,600,000 joules. So 1 kilowatt hour equals 3.6 multiplied by 10 to the power of 6 joules. The electrical energy used in homes and industries is expressed in kilowatt hour. The energy used during a month is expressed in units, where 1 unit means 1 kilowatt hour. Example 11.8. A boy of mass 50 kilograms runs up a staircase of 45 steps in 9 seconds. If each step is 15 centimeters high, find his power. Take g equals 10 meters per second squared. Solution. Weight of the boy. M multiplied by g equals 50 kilograms multiplied by 10 meters per second squared, which equals 500 newtons. Height of staircase, h equals 45 steps multiplied by 0.15 meters per step, which equals 6.75 meters. Time taken, t equals 9 seconds. Power P equals work divided by time equals open parenthesis. Nm multiplied by g multiplied by h close parenthesis divided by t. This equals 500 newtons multiplied by 6.75 meters divided by 9 seconds, which equals 375 watts. Power is 375 watts. Example 11.9. An electric bulb of 60 watts is used for 6 hours per day. Calculate the units of energy consumed in 1 day. Solution. Power of bulb equals 60 watts, which equals 0.06 kilowatts. Time used, t equals 6 hours. Energy equals power multiplied by time, which equals 0.06 kilowatts multiplied by 6 hours, which equals 0.36 kilowatt hours, or 0.36 units. The energy consumed is 0.36 units. Thank you for learning with us.